Still on Chapter 4, Section 4.5, Isotopes and Atomic Mass. Make sure that after this video you go and watch video problems 10 and 11 because they give you some more examples of calculating atomic mass from the isotopes. Alright, so a little definition here. Isotopes, they have the same number of protons but different number of neutrons. Okay, so the example down here is magnesium 24, 25, and 26. So here's magnesium 24. Alright, so it's got 24, that number on top, that's the mass number, over 12, that's the atomic number, which we know what those two things are, and then it's magnesium. Now this is what's called nuclear notation. There's also something called hyphen notation, which looks like this. Okay, so there's magnesium 24, here's magnesium 25. First of all, notice they have the same atomic number, which they have to because it's the same element. But now the mass number has changed. So that means magnesium 24 has 12 neutrons, while magnesium 25 has 13 neutrons. So those are isotopes. Same number of protons, different number of neutrons. Now, as it turns out, the atomic mass, which is shown on the periodic table, so the atomic mass is the weighted average mass of the isotopes of that element. Now what that means is if we find the isotope more often, then it factors more into the average. So isotopes found more often have a greater effect on atomic mass. So here's an example with chlorine. There are two isotopes of chlorine. There's chlorine 35, which chlorine 35 has a mass of 34.97. So you know this is right here. And then there's chlorine 37, which has a mass of 36.97. Now if they were found equally, so in other words I I grab a chunk of chlorine and I find that 50% of the time it's this, 50% of the time it's that, then I could just take the average. But they're not found equally. So I find chlorine 35 75.76% of the time. And then chlorine 37 I find 24.24% of the time. So that means that chlorine 35 has a greater effect on the atomic mass because it's found more often.